We will start by using the graph to the left and writing down everything we believe we know is to be true about this graph. First, we can identify that there are three linear pieces to this graph, and I have labeled them A, B, and C for clarity as we are describing the pieces. Segment A is actually a ray and has a domain of x less than or equal to -3. The range of the ray A is y equals -2. For B, we have a line segment. The domain is from -1 to -3. We can write this as -1, -3, less than or equal to x, less than or equal to -1. The range is from 4 less than or equal to y, less than or equal to 7. Our ray at C and the domain can be written as x greater than or equal to 0, and our range can be written as y also greater than or equal to 0. Now, I would like to propose the question, is this the graph of a function? First, we need to remember what the definition of a function is. A function is when there is only one output for every input. Basing my information off of this definition, my attention is drawn to when x equals 0. There are two values when x equals 0, and we want to determine what the output value is at x equals 0. We can begin by defining what the open and closed circles signify. A closed circle can be represented by greater than or equal to or less than or equal to. And this means that the point is included as a solution. An open circle can be represented by the symbols greater than or less than, and means that this point of x is not included in the function. We use an open circle to show that all the points in between and up until the x value of 0 and x value of -3 are included, except for x equals 0 and x equals -3. Based on our definition of a function and the definitions of a closed circle and open circle, we can check by evaluating the function at f of 0. Looking at the points f of 0, we see that there are 2 points, and I am circling them again. And we see that a closed circle means that the point is included in the function, and that an open circle signifies that the point is not included in a function. Therefore, at f of 0, our output value is 0. And I will rewrite this, that f of 0 does not equal 4. And this is because of the open circle. Now, let's look back and let's look at the domain and range of the entire function. A reminder, we can call this a function because there is no 2 output values for any given input value. Therefore, our domain is all real numbers. Now let's take a look at our range. Our range is the set of all possible output values. For segments B and C, our graph is defined for all values of f of x greater than or equal to 0. However, the function is not defined for the range of -1 or -1.5 or -0.5. To show this, we can say that it is defined for f of x is greater than or equal to 0, as well as f of x equal to -2. Since we have defined that this graph is a function, we can write an equation for the function. First, let's give this function a name. This function we have called f of x, but more specifically, this is what we call a piecewise function. As we had noticed previously, that each line segment and ray had a different domain and range. They also have different equations for each line. And this is exactly what a piecewise function is. It is a function that is made up of different formulas on different parts of the domain. Now we want to use our previous knowledge of writing an equation for a line. We begin for a piecewise function, f of x equals. However, we have more than just one equation. Beginning with the ray A, we can find the equation of the line. This line is y or f of x equals -2. We want to state for which domain, and we can say that it is for x less than or equal to -3. Our second piece, part B, we can start by finding the slope, which is rise over run. Here we see it has falls 1 and a run of 1, and so our slope is -1, and we can write this as negative x with our y-intercept of +4 for x between -3 and 0. However, we need to remember that -3 and 0 are not included in our function. We write this by saying -3 less than x less than 0. Now we can write the equation for our last segment. Finding the slope, we see that it is 1 over and 1 up, so we have a slope of 1 and a y-intercept of 0, so we can leave this as x. Writing the domain for this line segment, it is for x greater than and equal to, because 0 is included, to 0. And there we have the equation for our piecewise function.